Greetings and welcome once again to my new calculus channel. My name is John Gabriel. Today I'd like to explain to you what an equi-multiple means and how proposition 1 of Book V was misinterpreted by Sir Thomas Heath. What? I don't understand what's happening with this stupid recording thing popping up, and it's just weird. Anyway, Sir Thomas Heath didn't understand these things and didn't write them down as he should have. But that's probably because he wasn't Greek. So let's begin. Now, in the elements, proposition 1 says, if there are any number of magnitudes whatsoever, which are equal multiples, respectively of some other magnitudes of equal number to them, then as many times as the one of the first as the one of the magnitudes divisible by one of the second, so many times will all of the magnitudes also be divisible by all. So this is hard to understand. And basically, look, if you have the numbers, and it's not referring to numbers, the first thing you need to understand is that this here is not referring to numbers, okay? And nowhere in the Greek definition, which is right here, it says, "Ean I opasaun," I can't even pronounce that, meyethi, oposonun, meyethon, ison, okay? There's nothing about number there. I get angry when stupid people tell me that they know better than me. Pay attention, you morons. I know better than you. Okay, so this is wrong. Okay, it's got nothing to do with number. Number hasn't even come along at this stage and doesn't actually appear till Book VII. Okay, here in definition 2. Okay, so just very quickly, all the numbers you know of as, this is not related to proposition 1, but all the numbers you know of 1, 2, 3, 4, etc., they are all equi-multiples of 1. Okay. That's big. Why? Because they're all measured by 1. 1 is 1, 2 is 1 plus 1, 3 is 1 plus 1 plus 1, and so on. Okay. So the next thing I want to explain to you is that Heath and all the others who came before me and after Euclid didn't understand the difference between geometric measure and algebraic measure. So, for example, he said in his numbering modern notation, proposition 1 reads as that. Well, that's not correct. Okay, he should have said that the analogue in algebra is that. Then that would have been correct, because you don't have numbers in geometry, only in algebra. Do you understand that? Okay, and so what is the difference between geometric measure and algebraic measure? Well, very simply this. Let's go over it again, because a lot of you are incorrigibly stupid. Okay, so geometric measure. So geometric measure says that if you have a ratio, not numbers, a ratio like that, say like that, okay? Then this ratio that you're looking at here, this ratio here, has a property of quotientness. But we're not going to bother about that right now. Can you measure the red line with the green line? Yes, you can in geometry. Always, by the way. There's no exception. You can't tell me that if the red line is the circumference of the circle and the green line is the diameter of the circle, you cannot measure the circumference. Yes, you can, moron. I'm about to show you. This is what measure means. It means you take that, okay, and you measure 1, 2, 3, and this little bit here is just simply, I don't know what's happening now. That little bit there is just simply this part here, okay? Measures complete. So that means that you can take this green line, by the way, green line, okay, green line, and plus 3 of these, 1, 2, and 3. Concatenate them, and guess what? You measured this thing, okay, this magnitude. It's not a number, it's a magnitude, you stupid assholes. Right, let's go back here. So geometric measure, here's the definition. Write this down. Uses a physical unit or a magnitude and or parts of a physical unit. Unlike that idiot Frege who wrote that my realization and development of number is circular, I actually show you that it's not circular, and that everything else that morons that came before me did is not only circular but just flat out wrong. I mean, if you even look at the opposition to so-called opposition to mainstream, like Norman Wildberger, and guess what? He says that natural numbers are piles of ones. How stupid can you get? Natural numbers are piles of ones. You don't believe me? Go to academia and read his article. You'll see that I'm telling you the truth. Okay, so what I'm saying to you right now is you don't get to define these things, idiots. They are. Whether you thought of them ever or you didn't, they are. There's no way around this. There's no other way to do this. Okay, so what have I shown you right now? I've shown you geometric measure, which says that geometric measure says you use a physical unit and or parts of it to measure the antecedent, okay? Because by convention, the consequent measures the antecedent. There's no other way. Right. So what about algebraic measure? So what does algebraic do? Algebraic measure. So algebraic measure defines numbers through equi-multiples. No, equi-multiples are not numbers. I just told you that. Okay. So if you look at this article here, there's no circularity. Look, study this article here. There's no circularity whatsoever. By the time from steps 1 to 4, we don't have number. All we have there are ratios of magnitude and ratios of magnitudes. And in step 5, we get number, right? Where we get equi-multiples. So 1 is an equi-multiple of this green line, and 2 is an equi-multiple of this green line, and 3 is an equi-multiple of this green line. Okay, this green line here. Let's see if I can get a pen here. Well, I can't. Anyway, so study this article carefully. There's no circularity. It is the first rigorous definition ever of how number was realized. Okay, it did not evolve, it was realized. So now, in algebra, what's the difference in geometric measure? So in algebra, if you have circle circumference, which is a number, let's say c, and another number, well, it's not a number really. They're rational numbers. Like that, okay? So if you have something like this, what it means is you're looking at the attempted measure of this by this, okay? So you don't really have C, and you don't even know if you have either of these. So what you're trying to do in algebra is you're trying to measure this part. Now, you're trying to measure this part using the abstract unit. It doesn't matter what this length is because you can get circles with different circumferences, okay? Different circumferences and different diameters, okay? Right? So it doesn't matter what this unit is. But what you do now is you say you take this as the unit, which is 1, and or equal parts of it to measure the circumference. All right? That's the difference between algebraic and geometric measure. So let's go back here again. Geometric measure. So uses an abstract unit, which means its type and size is irrelevant, and or equal parts of an abstract unit. These distinctions are imperative in understanding the difference. Heath did not understand. No one after Euclid or before me understood. I am the first to tell you these things. So in algebra, the type or size of an assumed unit is irrelevant, as I just showed you here. If you're not already subscribed, become a subscriber to my channel. Click like, follow me on academia.edu. Now remember, to read these articles on academia, you need to create a free academia account, log in, and then go back to the links. That's the only way you'll read them. So don't write in my comment section, your links don't work. No, your brains don't work. Okay? So that's pretty much it. And then also I have a members only channel for €4.99 a month. You want to learn more? Become a member. Till next time, I'm John Gabriel. Goodbye.